Hello students, this is the video lecture covering section 11.5, Volumes of Pyramids and Cones. Our learning goal for this lesson is to be able to find the volume of a pyramid or the volume of a cone. So we start with theorem 11.8, which is the volume of a pyramid. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. So our first example is the entrance to the Louvre Museum in Paris, France. I thought I'd show you a picture I took of that entrance while I was in Paris in 2009. So the entrance to the museum is underground, and it's directly beneath this glass pyramid. That entrance is a square pyramid that has a height of about 21.64 meters, and the base edges are 35.4 meters. We want to find the approximate volume of that pyramid. So if we remember the formula, we have the volume of a pyramid is found as 1/3 the area of the base times the height of the pyramid. Since this is a square pyramid, we have 1/3. The area of the base is going to be side length squared times the height of the pyramid. So in this case, we get 1/3. The base edge is 35.4 meters squared times the height of the pyramid, which is 21.64 meters. Okay, so let's simplify this a little bit. We have 1/3. 35.4 squared is 1,253.16, and we're going to multiply that by 21.64. So, continuing to simplify, we have 1/3 of, multiplying these two numbers together, we get 27,118.3824. And finally, dividing this number by 3, we find that the approximate volume is somewhere in the neighborhood of 9,040 cubic meters. So this is in fact a very large pyramid. Our next question asks us to find the volume of a square pyramid that has base edges of 24 meters and a slant height of 13 meters. So let's start by drawing a picture. So here we have our square pyramid. Each of the base edges is 24. And the slant height, or the length from this vertex to the midpoint of one of the base edges, is 13 meters. So we know that the volume is 1/3 the area of the base times the height. So in this case, again, we have a square pyramid. So the area of the base can be defined as 24 squared. The height of the pyramid here is still an issue. We actually need to calculate the height of the pyramid. So you can see here, this is the triangle that we're dealing with. So let's go ahead and take a look at this triangle on a smaller scale. We know that the slant height is 13. Now, this is actually a very important spot in this pyramid. We can see we're connecting from the vertex to the center of the base because we know that this is supposed to be a right pyramid. So in this case, this is the actual center of the base. In other words, each of the base edges is cut in half. So we can use that to help us find the height of the pyramid. Now, hopefully we recognize that this is a Pythagorean triple, that this is a 5, 12, 13 triangle. However, if we didn't, we could find this by saying a squared plus 12 squared is going to equal 13 squared. Or a squared is going to equal 13 squared minus 12 squared. So a squared is going to equal 25, and that's going to give us the value of a, which as stated previously is in fact 5. So now that we know that the height of the pyramid is 5, we can go ahead and add that to our formula. 24 times 24 is 576. And we're going to multiply this by 5. 576 is divisible by 3. It's 192 times 5. And 192 times 5 is 960. And this is going to be in cubic meters. The final answer is 960 cubic meters. So Theorem 11.9 tells us the formula for the volume of a cone. The volume of a cone is 1/3 the product of the area of the base and the height of the cone. The picture illustrates something that's very important. If we have a cylinder and a cone that has the exact same base, it would take 3 cones to fill the cylinder. So the volume of a cone is 1/3 times pi times r squared times h. Our third question asks us to find the volume of a cone. So here we have a covering on a teepee that rests on poles that come together like concurrent lines. Remember, concurrent lines are lines that all meet at one specific location. The resulting structure approximates a cone. If the teepee pictured is 12 feet high with a base diameter of 14 feet, what is its approximate volume? Now I generally start questions like this by drawing a more mathematical version of the picture. So the teepee is 12 feet tall. So the height of our teepee here is 12 feet. In addition to that, we also know the base diameter, which is 14 feet. Now we know that the formula for the volume of a cone is 1/3 pi times the radius squared times the height of the cone. So let's go ahead and plug in what we know. We know that the 1/3 times pi, so now we need the radius. The radius is going to be half of the diameter. So 14 divided by 2 is 7. And the radius is going to be squared. The height of this cone is 12. Now, since multiplication is commutative, I'm going to take 1/3 of 12. So 1/3 of 12 is 4. I'm going to multiply that by 7 squared, which is 49, and then I'm going to multiply that by pi. 4 times 49 is 196. So this is 196 pi cubic feet. Now the question asks for an approximate area, so I would probably approximate this, and I'd probably round to the nearest cubic foot in this case. So that's going to give me something in the neighborhood of about 616 cubic feet. So at the beginning of the volume section of this unit, I introduced you to Cavalieri's principle. Due to Cavalieri's principle, oblique cones and pyramids have the exact same volume as a right cone or right pyramid of the same height. So problem 4 asks us to find the volume of an oblique cone. This is actually no different than finding the volume of a right cone. So it's the same exact formula. Volume equals 1/3 of pi r squared h. So in this case, we have 1/3 times pi. The radius here is 6. We're going to square that. And we're going to multiply that by the height of 12. Here again, I would take the 1/3 of 12, and I would say that that's 4. 6 times 6 is 36, and I'd multiply that by pi. 4 times 36 is 144, so this is 144 pi meters cubed. So that's our answer in terms of pi. If we want this rounded to the nearest cubic meter, we just multiply by pi using our calculator. And we find that this is about 452 cubic meters. That concludes this video lecture on section 11.5, volumes of pyramids and cones. Hopefully you understand how to find the volume of a pyramid and cone. Thank you for your attention, and I'll see you soon.